This past weekend marked the 7th and final week of my indoor biochar trial. In my last update, I showed how the kale results were consistent with our hypothesis that adding charged biochar to a potting mix at a rate of 5 to 10% would result in larger plant growth. However, the collard green results were not consistent with the hypothesis. In fact, the control group collards were quite a bit larger than those in the biochar groups. In this video, I'll revisit pepper seed germination rates and then share the size results for peppers and tomatoes. One of the hypotheses I wanted to test with this trial was that adding charged biochar to a potting mix at a rate of 5 to 10% would not have an impact on germination rates. The germination data for kale, collards, and tomatoes were consistent with this hypothesis. However, poblano peppers had lower germination rates in the biochar groups, especially in the 10% biochar group, where only 6 of 12 seeds germinated. Rather than conclude the biochar was having a negative impact on the germination of peppers, I decided to conduct another small test. I still had to plant jalapeno peppers and had enough space in my grow room for 8 pots. So I ran a test with 4 control pots with no biochar and 4 pots with 10% charged biochar. I planted 3 seeds in each pot for a total of 12 seeds per group. The germination rates were fairly low in both groups, with 8 out of 12 germinating in the control group and 7 of 12 in the 10% biochar group. However, the rates were close enough to be consistent with our hypothesis that biochar doesn't affect germination rates. So the germination results for kale, collards, tomatoes, and jalapeno peppers were all consistent with our hypothesis, while only the poblano pepper results were not. I then took specific measurements of all 12 pepper plants, 4 plants from the 0% biochar group, 4 from the 5% biochar group, and 4 from the 10% group. I measured the stem thickness at the base, the height of the plant from the soil to the top of the canopy, and the total number of healthy mature leaves. The average stem thickness did not vary much between the 3 groups, but the biochar stems were a little thicker. The 0% biochar plants had an average stem thickness of 4 millimeters. The 5% group had an average thickness of 4.1 millimeters, and the 10% group had an average thickness of 4.2 millimeters. So the results were consistent with the hypothesis, but the differences were minimal. Next, I measured the height of each pepper plant from the soil to the top of the canopy, and found that the control group peppers were the tallest, with an average height of 186.3 millimeters. The 5% group came next at 168.8 millimeters, and the 10% group were the shortest, with an average height of 150.3 millimeters. In this case, the more biochar in the potting mix, the shorter the plant. So clearly the height measurements did not support our hypothesis. Finally, I counted the number of leaves on each plant. Unhealthy leaves were removed before counting, and only leaves that had branched off from the stem were counted. Small leaves like these that were just starting to emerge were not included. The 5% biochar group had the highest average number of leaves at 14.5. However, the 10% group had the lowest average at 13. So the pepper plants in the biochar groups had thicker stems but were shorter than the control, and the leaf count results were mixed. Overall, the results for the peppers don't support our hypothesis that adding charged biochar at a rate of 5 to 10% of a potting mix will result in larger plant growth. Next, I moved on to the tomatoes. As with the peppers, I started with an informal observation of plant size by lining up the 4 tallest plants in order of height. In this case, all 4 of the tallest plants were all from the biochar groups, with the tallest 3 being from the 5% group and the 4th from the 10% group. I took measurements similar to those on the peppers, but also counted the number of branches on each plant. Interestingly, a biochar group took the lead on every single one of these measurements. The 5% group had the largest average stem thickness at 8.6 millimeters, and the 10% group had the second largest at 8 millimeters. I then measured the height of the plants. Once again, the 5% biochar group led in the height category. The average height of the 5% group was 22.9% greater than the control, and the average height of the 10% group was 5.2% greater than the control. Next, I counted the branches on each plant. I only counted those that had fully branched off from the stem. The average branch counts were pretty close. Once again, a biochar group, the 10% group, led this category, with an average branch count of 4.1% greater than the control. Finally, the leaves were counted on each tomato plant. Only mature leaves that had developed this characteristic leaf shape and veining pattern were counted. The biochar groups had more average leaves per plant than the control group, and the 5% biochar group led the way with 6.8% more leaves than the average control tomato. So while the pepper results were mixed at best, the tomatoes appeared to benefit from the presence of biochar. Both biochar groups outperformed the control on all criteria except for the fact that the 5% biochar tomatoes had a slightly lower average branch count than the control. Overall, though, the 5% biochar tomato plants were the largest. With the indoor biochar trial behind me, I'm not ready to draw any conclusions about the possible long-term benefits of biochar for my garden. Though it would have been nice to see decisive results in this 7-week experiment, the benefits of biochar may not be evident for a year or longer after it's incorporated into the garden. So this summer, along with several others from the Home Garden Field Trials community, I'll be conducting a biochar field trial. I plan to grow identical crops in 2 plots, a control plot with no biochar, and a test plot amended with pre-charged biochar. For the field trial, I'll be using biochar from biogenic reagents instead of the homemade biochar used in the indoor trial. Instead of simply measuring plant size, I'll be weighing the produce from both plots and comparing the results. I'll also take Brix readings and possibly do a blindfolded taste test. If I don't see decisively better results from the biochar this summer, I plan to repeat the field trial again in 2015. At that point, I hope to be able to make a decision if I want to continue using biochar in my garden. Well, that's all for now. Thank you very much for watching. And until next time, remember, you can change the world 1 yard at a time.